Hello everyone. Thanks for joining us again. Very excited to host another talk from one of our program PIs, Sebastien Gambs. Sebastien is a Canada Research Chair in Privacy and Ethical Analysis of Massive Data, and he is also a professor in the Department of Computer Science at the Université de Québec à Montreal. Sebastian's main research theme is privacy in the digital world. He is also interested in solving long-term scientific questions such as the existing tensions between massive data analysis and privacy, as well as ethical issues such as fairness, transparency, and algorithmic accountability raised by personalized systems. So welcome, Sebastian. The floor is yours.
So thank you for the introduction. So first, we are a small crowd, so if any of you have any question at some point, don't hesitate to ask. Just to say that also when I share my screen, I don't see the chat. So Calvin, maybe you can, if there is question on the chat that people can ask, if you can just ask them.
Sure. And you don't mind if we just do it in the middle, you don't want to wait to the end?
No, it can be in the middle, so people can also ask questions directly. I'm fine with any time.
Great, sounds good.
So basically, my objective today is to discuss the synergy and tension between privacy and other ethical issues, so mainly fairness and explainability. So what I will try to do is just give an introduction to this topic and then try to explain what we mean by privacy, fairness, and explainability in machine learning in a second part, and then I will try to discuss the synergy and tension. So when you want to implement these different ethical issues in a machine learning system, what are the situations where they converge together, and what are the situations where you also have to set some trade-off? So just to start on the introduction, so I'm sure you are all aware that since I would say a decade, we have seen what some people call a quantum leap or a deep learning revolution. So basically, I would say in 10 years, the tasks that can be solved by artificial intelligence and machine learning system have increased significantly. So now it's possible to have a computer system which is able to beat professional players on games like Go, which were considered to be difficult for artificial intelligence for a long time. We also have some tool where you can also generate directly a textual description from a picture. And if I take a even more recent example, if you have tried ChatGPT, you saw also that you have chatbots which are able to produce a text to a question that looks really in terms of quality like the one that an expert could do in many domains. And so these advances are possible basically due to three factors. The fact that machine learning researchers work a lot on doing new advances in terms of the algorithm to learn from data, but also the fact that the increase of computational power and the amount of data available is also increased quite a lot. So if you take these three factors together, we are now able to train systems to realize tasks that were considered difficult, I would say 10 years ago. And this success of machine learning models also means that there is more and more aspect on our daily life where these models are starting to be used in a system that impact individuals. So what I would call high-stake decision systems. So for instance, if you go to a bank and you ask for a loan, there is a good chance that your profile is going to be assessed by a machine learning algorithm to give you a score of representing the fact that you will be able to repay or not the loan. But also in the medical domain, we have a machine learning model which assists doctor in trying to identify tumor on radiography, for instance. And if you go to USA, you even have some country where there is a software used to predict the risk of recidivism if you release an inmate in advance. So if you have heard about the Compass system, which is this picture, basically, this is an example where really the prediction of the system are really affecting people in sense of letting people go or not from jail. And so the fact that we have the system used in more and more aspects of daily life also raise several ethical issues, which I will detail in the rest of my presentation. But just to mention that since I would say 5 years, we have seen a lot of initiatives to try to define what would be a responsible development of machine learning. So in Montreal, where I live, there was a Montreal Declaration for Responsible Development of Artificial Intelligence. So basically, it's an ethical declaration that tries to list the main ethical issues that need to be addressed when developing machine learning. In Europe, you have a new data privacy law since 2018, which also touch a bit on not only on privacy, but also on fairness and explainability, and I will come back to that also. And in Quebec, where I live, there is also a new regulation. We also touch a bit on this issue, but you might also know that in Europe, there is also no regulation specific to AI, which is currently being discussed. And there is also discussion in Quebec and at the federal level in Canada about doing also a regulation specific to AI. So this also increased the pressure for companies to try to show that they develop systems with privacy, fairness, and interpretability in mind. And so when they will have to implement this principle in the machine learning models that they use in their services, there will be also tension and synergy. And just to give a last example, that so some people are even saying that the change of or the pace of change of machine learning is so quick then maybe we should do a pause on the technology, which of course is difficult to do. So if you have this petition of putting AI on pause, you have, for instance, Elon Musk, which signed this petition, and a few weeks later, he started his own company on AI. So sometimes the motivation of people that have signed this petition can be very different from one another. And also, there is also a huge multiplicity of norms and guidelines on the ethics of AI. But one of the challenge, and this was the part of the objective of my work, but also a project that we conducted with other researchers, was to really try to see the intersection between privacy, fairness, and interpretability. So if you go on Google Scholar and you type privacy in machine learning, you will have thousands of publications. If you type fairness in machine learning, you will have also a lot of publications. But if you look at the intersection, there is very few work which have explored this different issue together. So part of what I will present today is based on my research, but also on this project. So I wanted also to acknowledge researchers which participate to this project. So Ulrich Ivody was a postdoc with me, but he is now a professor in ETS Montreal, also an engineering school in Montreal. And this was also done with Céline Castelrenard, which is a professor in law in Ottawa, and Ignacio Coffon, which is a researcher in law in McGill, and also ethician from UQAM, which are Dominique Martin and Anne-Marie Marcoux. And the report of the project is available here. So it was a one-year project funded by the Privacy Commission of Canada. So we try to explore the challenge at the intersection of privacy, fairness, and interpretability, not only from the computer science perspective, but also from the law and ethics perspective. So I don't know if you have a question on my introduction.
I don't see anything now.
So my objective now is, I would say, in 20 minutes to try just to give you a brief class on what it means to do privacy, fairness, and explainability in machine learning in kind of separate way. And then the rest of the talk would be to try to discuss the intersection, so the synergy and tensions. So when we look at privacy issue in machine learning, what we do, at least in the computer science view of the problem, is we try to imagine that we are an adversary and we have access to a machine learning model, usually by an API. So maybe you don't have access to the model directly, but you can ask questions to the model. So if you have tried ChatGPT, basically you are in the situation where maybe you have not downloaded the model, but you have used the API or OpenAI to ask questions. So this is the situation where, as an adversary, you give query to the model and you get prediction on answer. And then your objective is to try to deduce information either about the training set, which in general is personal data, or about the model itself. And either you want to attack the confidentiality of the model, but maybe you also want to conduct some privacy attack, which I will explain afterwards. So one thing which is important to realize, it's even if you sometimes have the impression that the model is called a black box, so if you think about what people call deep neural network, which are black box in the sense that it's very difficult for a human to understand the structure of the model and the prediction. This model actually captures a lot of information about the data itself. And so there is risk that people can reconstruct part of the training data just by interacting with the model. So the two extreme adversary models that people consider is the black box case where you just ask query. And sometimes you can be in the white box situation where you have full access to the structure of the model and you can also have access to the parameter. And this is like too extreme. In one case, you just ask question to the model and you get the answer. In the other, you can download the model. And just to say that the white box situation is not so uncommon because in machine learning community, there is I would say a tradition of sharing models sometimes. So even GAFAM, also big tech group like Meta, for instance, have the tendency to share the models sometimes. And so usually what we do when we try to do a privacy attacks against a model is to use the weaker model where you just give the adversary the possibility to ask questions. And what you are trying to show when you design attack in this setting is to show that there is some privacy issue where the adversary might be able to retrieve part of the information about the training set just by doing this query. And because it's a weaker privacy model, if you show that such an attack is possible, then you show that if you were in a stronger privacy model where the adversary has access to the full knowledge, he will be able to learn even more information about individual. So one type of attack that people study, for instance, is what we call membership inference. So basically, you know the profile of a particular person and you try to decide if he was in a training set. So just to give a picture, so basically, for instance, you have this picture of a car and you would like to know if this picture was in the training data, but imagine that this could be also the profile of a person. And maybe the model could be a model of trained on patient from an hospital. And the goal of a membership inference is to learn one bit of information on whether this person was part of the training data set or not. And usually you exploit the prediction of the model to do that. So one thing that happens very often is that if your picture was part of the training data set, usually the model is very confident about the prediction that it makes. So it will say it's automotive with a very high confidence. But if it was not in a training set, usually the model will be less confident. So one way to do, for instance, a membership inference attack is to use the vector of prediction. And so why is it a privacy breach? Imagine that, remember, the training set is composed of patients that have a particular disease. If I can do a membership inference, I can basically decide if this particular profile has this particular characteristic. But maybe the training set could be also member from a particular minority group of the population. So you can imagine that it can be used to disclose sensitive information. And why it seems to be a very simple attack, it's often a sign if you can do such an attack is that you can also potentially do more complex attacks. And I will give an example of some of these attacks. And so just to say that to do such an attack, some people have proposed that, so the first paper was from 2017. So you see that it's not so old. It's, I would say the research in it field like maybe 6 years old for the older paper, and there is a lot of more recent paper, but the way they do that was with a technique called shadow training. So you don't need to understand the details about it, but basically what you do is you learn a lot of model where either the particular profile was in the training set or not, and you try to learn a meta classifier which can distinguish between the in and out world, and you can use this to do a membership inference attack. But basically, the more recent attacks, they only use the prediction vector. So for the first attack, it was very complex. You need to train a lot of model. You need to have a lot of data coming from the same population. But with the more recent attack, which are even more efficient than the older ones, you can just exploit the confidence of the prediction. And other attacks that people try to do also is to try to show that you can reconstruct part of the training data set directly just by asking query to the model. So imagine that you get the impression that the model is a black box model, but if you can retrieve half of the training data basically is like if you publish directly the training dataset or part of the training dataset. People have also worked on attack with what they call model extraction. So it is about creating locally a copy of the model, which is quite faithful in terms of prediction. So it's more an attack on security. And one example of use case that I can imagine is, so imagine that you have a startup which has spent millions of dollars to create a particular model. And the startup try to sell the use of the model to other company. If you are able to do a model extraction attack, it means that basically you can locally create a copy of this model just by doing some queries. And so you could also start your own competitive business, just saying that you have also the same model, but without spending as much resources and data to create it. But also if you have locally a copy of the model, it means that you are now in the white box setting where you have access to a model which looks like the original black box, so you can also use it to do some privacy attacks. And other attack which people try to study more recently is more about groups. So most of the attack I described previously was more about, can I deduce something about a particular individual? But people have also tried to show that sometimes you can deduce information about subgroup of the population. So for instance, there is paper which shows that they were able to identify the ethnicity of individual used in a speech recognition system. So it's a kind of software that I use when you, basically if you have a vocal assistant at home where you give a particular vocal command and the speech recognition system is able to translate it to text. But also some people have shown that it's possible to predict what it was the percentage of male and female in the population just by doing query to the model. So this is about learning information about subgroup of the population. So this particular privacy route is possible because sometimes models tend to remember too much the data. So machine learning people would call it overfitting. So if you train your model and it memorizes too much the original data, then often this privacy attack will be possible. But also the more complex and the bigger your model is, the more also the possibility of privacy attack is possible. So if you, coming back to ChatGPT, GPT is what people call a large language model because it's billion of parameters and in terms of size is huge. And usually when you have a large model, all the attacks that I mentioned will also work with an increased success because basically the model has more space to remember data about people that they have seen in the training set. And so to avoid this kind of attack, people use a privacy model, which is called differential privacy. So I don't want to give any equation today, but basically what differential privacy will guarantee is that when you have a learning algorithm which is trained on data, you are going to limit the influence of a particular point. So what you do is imagine that you have two data sets, one where you have millions of individuals, but you have not a particular profile, and the other which is the same, but where you add an additional profile. What you do with differential privacy is you guarantee that the model that is learned is not influenced by this particular profile. So basically, you are still able to learn a model which depends on the data of all the people, but it will not memorize information about a particular individual. So if you are the adversary and you observe the model or you observe the prediction of the model, there is very little information that you can use to do the privacy attacks that I mentioned. And this was invented in 2006, but I would say that it's only been like 10 years since people have tried to use it as a protection mechanism in machine learning to avoid the attacks that I mentioned. And there is a lot of way to implement differential privacy in machine learning. If you ever see the term in a presentation from a machine learning person called DPSGD, it's basically the introduction of differential privacy in the stochastic gradient descent, which is a way to train deep neural network. But there is a lot of other way where you can either randomize the algorithm, perturb the input, or even perturb the outputs. So I just wanted to mention that there is also a lot of different work in this area since I would say 10 years ago. Okay, so now is there any question on the privacy part of machine learning?
Nothing in the chat yet. Does anyone want to
Okay, so now I'm going also in a few slides to try to explain what fairness in machine learning means, and just to come back to the idea that why we don't have in Canada or in Quebec yet a regulation on AI. You see that there is already privacy legislation in Europe where the right to fairness is already part of the legislation. So in the GDPR, which is a regulation in Europe, basically it says that if you have a service or if you have a company that use your personal data, basically the controller, so the company should put in place all the appropriate mathematical and statistical procedures to limit the risk of inaccuracy, in particular to prevent discriminatory effect based on the race, the ethnic origin, the political opinion, the religion, etc. So I just mentioning that to say that also we don't have yet AI regulation which says that fairness is one of the main ethical issues to address. You see that already in the privacy legislation, there is some provision about the right to fairness. And so if you go back in time and you were a PhD student 10 years ago, I would say it would have been good for you instead of being able to do your literature review maybe in 6 months. But just to say, similarly to privacy, the number of papers in fairness in machine learning has also exploded. So this was a cartoon from Maurice Hart, which is a professor in US, giving a class in fairness in machine learning. And basically, you really need to scope your literature review because the number of papers, if you type fairness in machine learning on Google Scholar, are also exploded. But basically, what it means for machine learning model to be fair, there is different families of fairness notion, but one would be what people call individual fairness. So the idea would be, imagine that you have a machine learning model which is used to analyze your CV and to predict what will be the salary for a starting job in a company. Individual fairness would mean that the prediction of the system should be the same if you have similar profile. So especially if you have two CVs that are identical, except maybe for the gender of the person, if you want to achieve individual fairness, you hope that the prediction of the salary would be the same. So there will be no difference if the profile are similar. But this look really at how the model behave on similar profile. But another notion of fairness is more about group statistics. So when you do group fairness, you look more at the population level. If for instance, the probability of female and male being accepted in this company are the same. So it's more trying to equalize the statistic of decision about groups of the group of the population. And these two family of fairness notion, I would say, if you look at the rationale, they make sense, but there is also work which shows that sometimes you cannot have both of them. So if I can give you a quick example, imagine that you are building a system where you want to scan for a particular school to decide if a particular profile of students should be accepted or not. Sorry. And imagine that on average in the population, female have better grades than male. If the system only look at the grades, it means that on average, you will have more female accepted than male. So the system will not have group fairness, but basically it will have individual fairness. If you have two people which have the same grades, they will have the same chance of being admitted or not. So if you will have individual fairness, but not group fairness. So if you want to have group fairness, you could do a kind of affirmative action where you say, okay, we know that male on average are not as good in terms of grade as female. So maybe I'm going to give a few extra points to any particular person which come from this group. So in this case, you could equalize the acceptance rates of male and female. But basically, it means that if you are a male, you are going to get extra points directly. So it's not, it doesn't preserve individual fairness anymore. So this is just an example where you have to make decision on the fairness notion that you need to choose. And if you are interested to know more about the fairness definition and also the tension between these different definitions, there is a tutorial on YouTube called 21 fairness definition and their politics. So the politic in sense of what is the rationale behind the notion, and it's give you it's called also a translation tutorial. So it's meant to translate the work in computer science and mathematics to an audience that is non-technical. And it will give you also a very good tutorial on this notion, but also one of the main messages is that in contrast to privacy, where differential privacy is now used as a gold standard to protect privacy, in fairness, I mean, one of the things that is likely to happen is depending on your use case, your application domain, and your context, you are likely to have to make a choice on what is the fairness definition that seems the more appropriate for this particular context. So it's likely that the fairness notion that you choose is going to be context dependent and dependent on the use case. And also, similarly to privacy, there is a lot of work in the literature on people on how to enhance fairness. So basically, you can modify the data to remove some bias. So going back to my example of you are trying to predict the salary of person, if you know that for 40 years, the salary of men and women is not the same, there is a high disparity. One thing you can do is, instead of giving the data directly to the machine learning model, which will only reproduce the bias, you can try to correct, for instance, the salary in the data. So you might modify the original data to try to remove the bias before you give it to the machine learning model. But also one thing you can do is, instead of just optimizing for accuracy of prediction, you can also try to optimize for fairness at the same time. So in processing method, try to optimize not only for the prediction accuracy, but also for the fairness notion. And even if you learn a model and sometimes you can post-process, so you can modify, for instance, in a neural network, some connection to remove the impact or the influence of some attributes to decorrelate the decision from the gender or from sensitive attributes. And once again, there is no one solution that works in all contexts. It will depend on what is the fairness notion that you want, but also what is the use case or the application that you have. And also I want to mention that sometimes there is a way to be perfectly fair, which don't make sense. So for instance, if you don't look at the profile and you just flip a coin to decide if somebody is accepted or not, you can say it's perfectly fair, but you don't use at all the utility in the information that you have. So we need to be careful about that. And also one thing I want to mention is fairness is even computer scientists, most of them understand that it's not only the technology that will solve the issue, it's also depend about the techno-sociological system. So often you also need to, when you deploy the fair system, to ensure that you could have some feedback loop where you have effects that are long-term effects that are not foreseen at the beginning, and so you also need to be careful about how you use this particular fair model in which situation, and maybe it will just help, but it will not solve the cause of a problem. So maybe the discrimination issue is not because of the model itself, but it's because of some inequality in the population. Okay, is there some question on the fairness part?
Not necessarily questions, some comments though. Maybe we could get into them afterwards. Unless Fanny, do you have something that you want to jump in with?
No.
Okay, let's keep it going.
Okay, so maybe I will finish the explanation part, and then we can take a look at the comment before going to the last. So about explainability, I would say is the third requirement that we will look today. So here also you see that even in the GDPR, you have a provision about explainability. So basically it says that if you have a decision which has a legal effect on a person based on automated processing, so it could be a machine learning model, but it could be another also computer's system, then you need to provide information to the user about why was the decision reached. So there is also this notion of, people call it a right to an explanation. So there is a lot of debate about what would be the good form of explanation, but at least we also show that if the prediction impacts a person, there is a right to ask for an explanation about the decision. And so I would say in explainability, there is also two branches of research. So the first one, which I would call interpretability, is to directly use a machine learning model which has a structure that make it possible to explain easily the decision. So in some situation, maybe we don't want to use a neural network, but we want to use a model where it's very easy to explain the prediction. So for instance, This is a decision tree based on the Compass datasets. So basically, to explain whether you should release a person or not, you just have to look at the root and you ask question on a particular attribute on the profile, and based on the value of these attributes, you go left or right. And when you reach a leaf, basically this corresponds to the prediction. So for instance, if we are in this particular leaf, basically you could say to the person that it was okay to be released because based on the model learned, he has his number of prior is more than 3, sorry, less than 3, but is also above 26, and you see that he has different characteristics. So it's very easy to explain the path of decision. So this is one of the possibilities to use directly a model which you can interpret. And the other branch of research, which is more about explainability, it's sometimes people call it also explainable AI. So if you have seen the acronym XAI, basically this is all the line of research where you have a machine learning model, which is possibly a black box like a deep neural network, and you try to come with a method which a posteriori, so you don't create the model with explanation in mind, but after the model has been trained, you try to design explanation. And one example of such explanation could be, for instance, what are the attributes in the profile that had a lot of weight in the decision. So for instance, there is a system called LIME, which will say that for the prediction on the particular profile of a person, to say that this person is likely to have flu, the factors that have a lot of impact in this prediction was the fact that the person was sneezing and had headache, and also that he was showing no fatigue. So this is trying to do kind of a local explanation, or for a particular profile and prediction, you try to decide what was the features that had a lot of importance. But people have also worked on global explanation, where basically you learn an interpretable model which is faithful to the black box, and then you use the interpretable model to try to explain the decision of the black box. Okay. And now I've finished with my second part, so maybe I can have a look at the comments, or if people have questions.
Do you want to move into discussion now, Sebastien?
Yeah, just take question if there is before.
Okay. I'm gonna stop the recording then.
I mean, yeah. So Fanny, you have a suggestion about